Long before Homo sapiens expanded across the continents, another human lineage had already established itself as a dominant presence on Earth. This was not a marginal or short-lived population, but a widespread and biologically successful form of humanity that endured for hundreds of thousands of years. In an unstable world shaped by extreme climates and powerful predators, this ancient population achieved something rare in evolutionary history: long-term survival combined with territorial dominance. Before we dive back in, drop a comment and let us know where you're watching from and what time it is there. We love seeing how far these episodes travel. And if you're enjoying the content, hit that subscribe button. It really helps us keep bringing deep, fascinating stories to the Primal Roots channel. And to everyone who's already subscribed and supporting the channel, thank you for being part of this journey. We truly appreciate you. Between roughly 800,000 and 200,000 years ago, during the Middle Pleistocene, the planet experienced repeated cycles of glaciation, shifting ecosystems, and dramatic environmental stress. Forests expanded and collapsed. Open savannas spread across vast regions, and megafauna flourished alongside growing human populations. Thriving under these conditions required more than physical endurance. It demanded adaptability, cooperation, and practical intelligence capable of responding to constant uncertainty. The archaeological record indicates that this human lineage possessed all of these qualities. The earliest evidence of their existence does not come from a single discovery, but from a recurring pattern found across multiple regions. Highly standardized stone tools began appearing almost simultaneously in Africa, Europe, and parts of Western Asia. These were not crude or improvised objects. They were carefully shaped implements produced through consistent techniques, suggesting planning, skill, and the transmission of knowledge across generations. Such uniformity points to large, interconnected populations, capable of maintaining cultural continuity over long periods of time. Fossils associated with these tools reveal individuals who were clearly human, yet anatomically distinct from modern Homo sapiens. They had elongated skulls, prominent brow ridges, thick cranial bones, and compact muscular bodies. These physical traits were not random. They reflect direct adaptations to cold temperatures, physical demands, and high-energy lifestyles. Importantly, their brain volumes often matched or even exceeded the modern human average, demonstrating that cognitive limitations do not explain their eventual disappearance. These humans occupied caves, rock shelters, and open landscapes, exploiting a wide range of ecological niches. Cut marks on animal bones provide strong evidence of organized hunting strategies, including the cooperative pursuit of large mammals. Fire was already under controlled use, serving multiple purposes beyond warmth. It transformed food, extended daily activity into the night, protected camps from predators, and allowed settlement in colder regions. Such behaviors imply structured communication, shared responsibilities, and social coordination. For hundreds of thousands of years, this population maintained an extraordinary level of territorial control. There is no indication of sudden collapse or rapid replacement. Instead, the archaeological layers suggest continuity, regional adjustment, and prolonged success. From an evolutionary standpoint, this represents one of the most enduring human lineages ever documented, even though it remains largely unknown outside academic circles. One of the most intriguing aspects of this ancient population is the absence of a single, universally accepted name. Fossils attributed to this lineage have been classified under various labels, including Homo heidelbergensis, or broadly defined archaic humans. This taxonomic ambiguity reflects scientific caution rather than insignificance. Their position within the human evolutionary tree is complex, occupying a critical transitional space between earlier hominins and later human forms. As time progressed and environmental instability intensified, selective pressures increased. Some groups began diverging regionally, while others vanished altogether. It was during this dynamic period that the earliest representatives of Homo sapiens gradually emerged. However, when sapiens first appeared, the world was far from empty. The landscapes they entered were already mapped, exploited, and shaped by populations that had mastered survival over immense spans of time. The Earth inherited by Homo sapiens was not an untouched frontier awaiting conquest. It was a planet long occupied by experienced human groups who understood migration patterns, seasonal cycles, and ecological limits. Recognizing this reality challenges the simplified narrative of human origins and forces a re-evaluation of how modern humanity came to dominate the globe. The persistence of this lineage for hundreds of millennia was no accident. Survival in a volatile environment required stable social systems, continuous learning, and collective adaptation. Archaeological evidence points to organized communities capable of sustaining large groups across generations. Settlement patterns reveal repeated use of specific locations, indicating memory, planning, and environmental knowledge passed down over time. Cooperation appears to have been a defining feature. Sites often show distinct areas for tool production, food processing, and rest, suggesting functional spatial organization. Such consistency cannot emerge without communication and shared norms. The repetition of these patterns across vast geographic areas reinforces the idea of a strong cultural foundation rather than isolated improvisation. Technology played a central role in their success. The stone industries associated with this population, especially bifacial tools, display remarkable symmetry and consistency. Producing these implements required careful selection of raw materials, precise control of force, and a clear mental image of the final form. This level of craftsmanship reflects abstract thinking applied to real-world challenges, a hallmark of human intelligence. These tools were not merely weapons. They extended physical capabilities, enabling efficient hunting, cutting, digging, and defense. Their effectiveness allowed exploitation of a wide range of prey, including large herbivores of the megafauna. Fossil remains show systematic butchery and full use of animal resources, from meat and fat to bones and hides, indicating an economy focused on efficiency rather than excess. Fire represented a turning point. Repeated hearths demonstrate that fire use was habitual and embedded in daily life. It expanded dietary options, reduced disease risk, increased caloric intake, and transformed living spaces into controlled environments. Fire also served as a social focal point, reinforcing group cohesion and shared routines. Ecological flexibility was another key advantage. Different groups adapted to open grasslands, temperate forests, coastal zones, and semi-arid regions. This versatility suggests deep environmental awareness rather than reliance on a single habitat. Instead of being specialists locked into one ecosystem, these humans adjusted strategies as conditions changed, displaying advanced behavioral plasticity. Mobility further enhanced survival. While certain areas were revisited repeatedly, these groups were not permanently fixed. They moved strategically, following water sources, animal migrations, and seasonal abundance. This reduced pressure on local resources and increased resilience during periods of scarcity. Distribution maps indicate that these populations were responsible for some of the earliest large-scale human expansions beyond Africa. As populations grew and territories expanded, contact between groups became unavoidable. Cultural exchange likely occurred alongside competition. While direct evidence of conflict is limited, skeletal injuries suggest occasional physical confrontations, reinforcing the idea that valuable territories were defended when necessary. Cognitively, these humans demonstrated long-term planning. Tools were prepared in advance, resources were stored, and occupation sites were selected strategically. Such behaviors require collective memory, shared learning, and decision-making based on past experience. These traits are essential for any species that achieves prolonged dominance. The evolutionary longevity of this lineage reveals a highly efficient way of life. While many hominin species appeared briefly and disappeared, this population maintained stability across immense timescales. This balance between biology, culture, and environment challenges the notion of primitiveness often assigned to ancient humans. Yet stability did not mean stagnation. Over time, Regional differences emerged in anatomy, technology, and subsistence strategies. Some groups followed distinct evolutionary paths, while others remained more conservative. This mosaic of variation created the conditions for major evolutionary transitions that would unfold later. As the Pleistocene continued, climatic oscillations intensified. Landscapes were repeatedly reshaped, imposing new selective pressures. It was within this constantly shifting world that new human forms began to arise. Among them was Homo sapiens, entering a stage already built by those who came before. Understanding this lineage is essential to understanding ourselves. The rise of Homo sapiens did not begin from nothing. It emerged from a world long shaped by ancient humans whose influence still echoes through biology, culture, and survival strategies today. The emergence of Homo sapiens did not mark an immediate turning point in human history. Instead, it initiated a prolonged period of coexistence between multiple human populations, each shaped by distinct evolutionary paths. When the earliest sapiens groups began expanding beyond Africa, they entered landscapes already occupied by experienced human communities that had adapted to local environments over hundreds of thousands of years. These encounters unfolded gradually, across shifting climates and complex ecological networks. Archaeological evidence increasingly supports scenarios of long-term overlap rather than abrupt replacement. In several regions, tool industries associated with different human traditions appear in close succession, or even within the same stratigraphic layers. This pattern suggests alternating or shared use of territories rather than a single wave of displacement. Such arrangements required tolerance, awareness, and a practical understanding of resource boundaries. Homo sapiens displayed behavioral traits that proved advantageous under certain conditions. Wider social networks enabled cooperation across greater distances, allowing information about food sources, migration routes, and seasonal risks to circulate rapidly. Symbolic communication, more flexible than that of earlier populations, strengthened group identity and facilitated coordination beyond immediate kin groups. In unstable environments, this collective intelligence increased resilience. At the same time, archaic human populations were neither passive nor technologically inferior. They possessed deep ecological knowledge of their territories, refined hunting methods, and established social structures that supported long-term survival. In many regions, these groups continued to thrive long after sapiens' arrival, demonstrating that dominance was context-dependent rather than universal. The interaction between these populations was not limited to competition. Genetic evidence confirms repeated episodes of interbreeding. Segments of archaic human DNA persist in modern populations, particularly outside Africa, indicating biological integration alongside cultural contact. These inherited genetic variants influenced immune responses, cold tolerance, and metabolic efficiency, providing adaptive benefits in challenging environments. Over extended periods, however, small advantages accumulated in favor of Homo sapiens. The ability to form large, interconnected alliances allowed innovations to spread rapidly and reduced the risks associated with isolation. As sapiens groups expanded, they increasingly occupied strategic corridors and resource-rich zones, gradually restricting the range of other human populations. Environmental change amplified these pressures. Intensifying glacial cycles fragmented habitats and reduced habitable areas, concentrating populations into ecological refuges. In these constrained settings, competition for resources became more pronounced. Groups capable of rapid social reorganization and flexible subsistence strategies were more likely to persist. Some archaic populations were absorbed into sapiens communities, others retreated into marginal zones, and some vanished without leaving clear archaeological traces. The disappearance of these ancient groups was neither uniform nor synchronized. In certain regions, archaic humans persisted for tens of thousands of years alongside sapiens, adapting to local conditions with remarkable resilience. Elsewhere, populations declined earlier, possibly due to climatic extremes, demographic isolation, or cumulative ecological stress. This uneven pattern underscores the absence of a single cause behind their decline. From an evolutionary perspective, this period represents a gradual transformation rather than a sharp boundary. Homo sapiens did not arise in isolation, but inherited a world structured by prior human activity. Many survival strategies, technological foundations, and ecological adaptations had already been established. Sapiens' success involved reorganizing and amplifying existing systems, rather than inventing humanity from scratch. The challenge of clearly identifying these ancient populations in modern classifications reflects the fluid nature of human evolution. Genetic exchange, regional divergence, and recurring contact blurred the lines between groups. Species boundaries were porous, shaped by movement and interaction rather than rigid separation. The loss of a distinct population name does not imply the loss of influence. Traces of this legacy remain embedded within the modern human genome. Certain physiological traits and adaptive responses carry signatures inherited from these ancient lineages. Although they no longer exist as separate populations, their contributions persist within the biological fabric of humanity. Re-examining this shared past reshapes the understanding of what it means to be human. Human evolution is not a linear ascent, but a network of intersecting paths, marked by cooperation, competition, and convergence. The dominance of Homo sapiens emerged from this complexity, built upon the foundations laid by those who came before. The transition to modern humanity was therefore not a moment of replacement, but a long process of interaction and integration. Each surviving population influenced the outcome, leaving traces that continue to shape human biology and behavior. Recognizing this continuity reveals that modern humans are not separate from the ancient past, but a living extension of it. The dominance of Homo sapiens was not the result of a sudden evolutionary breakthrough, nor did it emerge in isolation from earlier human history. It unfolded through a prolonged process shaped by inherited adaptations, environmental pressures, and the cumulative knowledge of populations that preceded modern humans. The ancient lineages that once occupied vast portions of the planet did not vanish without consequence. Instead, their influence persisted, woven into the biological and cultural foundations of humanity. Genetic research has transformed the understanding of this legacy. Advances in ancient DNA analysis have revealed that modern human populations carry fragments of genetic material inherited from archaic humans. These genetic sequences are not evenly distributed across the globe. They appear more frequently in populations whose ancestors migrated into Eurasia, reflecting repeated contact and interbreeding events. Such findings confirm that human evolution involved integration rather than strict replacement. Many of these inherited genetic variants have functional significance. Some are associated with immune system responses, enhancing resistance to pathogens encountered in unfamiliar environments. Others influence skin physiology, oxygen processing, and cold tolerance, traits that proved advantageous during expansions into harsher climates. These adaptations did not arise spontaneously in Homo sapiens, but were acquired through interactions with populations already adapted to those conditions. Physiological traits in modern humans also reflect this deep evolutionary layering. Variations in bone density, cranial shape, and metabolic regulation show patterns that cannot be explained by recent evolution alone. Instead, they point to contributions from ancient populations that experienced different selective pressures over long periods. The human body is therefore not the product of a single lineage, but a composite shaped by multiple ancestral sources. Behavioral inheritance extends beyond genetics. Many fundamental aspects of human survival strategies were established long before the emergence of fully modern behavior. Techniques for hunting, resource sharing, seasonal movement, and environmental management evolved gradually across earlier populations. Homo sapiens refined and expanded these practices, but their origins lie deep within the shared human past. Archaeological records reveal continuity in tool-making traditions across transitional periods. Rather than abrupt technological revolutions, gradual modifications dominate the evidence. Stone tools became more specialized and diversified, yet they retained structural principles developed by earlier humans. This pattern suggests cumulative learning, where innovation builds upon existing frameworks rather than replacing them entirely. The development of complex social systems followed a similar trajectory. Group cohesion, cooperative child-rearing, and collective decision-making were essential for survival in ancient environments. These social dynamics existed long before symbolic expression became prominent. Modern social behavior therefore represents an elaboration of earlier systems, not a radical departure from them. Language, often considered a defining feature of Homo sapiens, likely evolved incrementally. While the full complexity of modern language is unique, its foundations may trace back to advanced communication systems present in earlier populations. Neural structures related to speech and auditory processing show deep evolutionary roots, suggesting that the capacity for complex communication developed over extended timescales. Cultural transmission played a critical role in maintaining continuity across generations. Knowledge related to tool production, hunting strategies, and environmental awareness was preserved and adapted through social learning. This capacity allowed human populations to respond flexibly to changing conditions without relying solely on biological evolution. Cultural inheritance became a powerful force, accelerating adaptation beyond genetic limits. The eventual dominance of Homo sapiens reflects an amplification of these inherited advantages, rather than a complete reinvention. Expanded social networks increased the speed at which ideas spread. Symbolic expression strengthened group identity and cooperation. Technological flexibility allowed rapid adjustment to diverse environments. Each of these traits had precedence in earlier human populations, refined through long periods of experimentation and survival. The disappearance of distinct archaic populations does not imply evolutionary failure. On the contrary, their long-term persistence demonstrates exceptional success within their environmental contexts. Their absorption into sapiens populations represents a transition rather than extinction. In evolutionary terms, contributing to future generations is itself a form of survival. Climate change continued to shape this process. Repeated glacial and interglacial cycles altered landscapes, redistributed resources, and reshaped migration routes. Human populations that could combine biological adaptability with cultural innovation were better positioned to endure these fluctuations. Homo sapiens benefited from both inherited traits and emerging social complexity, allowing sustained expansion under unpredictable conditions. As populations grew and interconnected, regional differences gradually diminished. Gene flow increased, technologies converged, and cultural practices blended. This process created the foundation for a globally distributed species capable of occupying nearly every terrestrial environment. Yet beneath this apparent uniformity lies a layered evolutionary history. Modern humans often perceive themselves as separate from the ancient past, but biological evidence challenges this view. Each individual carries genetic markers reflecting encounters that occurred tens of thousands of years ago. These markers influence health, physiology, and adaptation in subtle but measurable ways. The past is not distant, it is embedded within the present. Understanding this continuity reshapes interpretations of human uniqueness. Intelligence, creativity, and adaptability did not appear suddenly. They emerged through cumulative processes involving multiple populations over vast spans of time. Recognizing this shared inheritance shifts the narrative from one of conquest to one of convergence. Human evolution is best understood as a network rather than a ladder. Lineages diverged, reconnected, and influenced one another repeatedly. The success of Homo sapiens emerged from this interconnected system, not from isolation or supremacy alone. Evolution favored integration, flexibility, and cooperation across boundaries. This perspective also reframes the concept of dominance. Rather than eliminating all competitors, Homo sapiens absorbed, learned from, and incorporated other human populations. The result was not a single lineage triumphing over others, but a synthesis shaped by countless interactions. The invisible legacy of ancient humans continues to shape modern life. Responses to climate, disease, and environmental stress carry traces of adaptations forged in deep time. Cultural tendencies toward cooperation, innovation, and resilience reflect survival strategies tested long before recorded history. Recognizing this legacy deepens the understanding of humanity's place within the natural world. Modern humans are not separate from earlier forms, but their continuation. The boundaries between past and present blur when viewed through an evolutionary lens. The story of human origins is therefore not one of replacement, but of accumulation. Each generation inherited not only genes, but knowledge, behaviors, and strategies shaped by those who came before. Homo sapiens emerged as the dominant human population because it carried forward the strengths of many lineages, integrated into a single, adaptable species. This realization transforms the understanding of human history. The ancient populations that once dominated the planet did not disappear without trace. They persist within modern humanity, forming the unseen foundation of who humans are today and how they continue to adapt in a changing world. If this content expanded your understanding of human origins and the invisible influences we still carry, subscribe to the channel, like the video, and keep exploring the evidence that reveals humanity's forgotten past. See you in the next episode.